All right, let's get started. This is 1-4, sketching. All right, you ready?
I'm ready.
Okay, just making sure. Seemed kind of noisy for being ready. All right, learn sketch the graphs of functions. You can use key features of a function to sketch its graph. The domain is just our x values, correct? Goes left and right. Domain is our y values. Intercepts are where it crosses the x or y axis. Symmetry is a reflection or rotation of the other side. End behavior the graph is doing, what the graph is doing is it goes right and left as x approaches infinity or negative infinity. Extrema is just where the graph curves. Increase, decrease means it goes up or it goes down. Positive or negative means the y values because it's in reference to the x-axis. Example 1, which they already did it for you, so I'm a little confused. Well, that's example 1, but that's okay. What it's going to do is give us this part here and want us to fill out the graph on the right. So it wants a y-intercept at 0, -70. Is that crossing at 0, -70? Yes. Is it linear? It is a straight line, so it's linear. All right, see how it says positive for values of x such that x is less than or less than -30? Right here is -30. And isn't this like -70 right here? That's less than -30, correct? Yes. So when it hits -30 and all numbers, all x values smaller, it's going to be positive. So it means its sign is positive. When it's greater than -30, your signs are negative, your y values. It's decreasing, it's going downhill. So all values are decreasing. My end behavior, I was so proud on how you guys did on end behavior. As we go to the right, it goes down. As it goes to the left, it goes up. That's it. Not super difficult. All right, let's turn the page. All right, example 2, sketch a non-linear graph. That means a graph that's not a straight line, non-linear. Use the key features of the function to sketch the graph. Y-intercept, where's my y-intercept going to be?
0, 3.
So go over 0, up 3, and put a point, please. The next thing we know, so 0, 3, I put a point there. Continuity, continuous, that means there's going to be no breaks in our graph. Non-linear, positive for all values of x, so that means it's not going to cross the x-axis. It has to be positive. Decreasing for all values of x such that x is less than 0. So that means on the left side of the graph, it's going to be decreasing, and on the right side of the y-axis, it's going to be increasing. Extrema, the minimum's at 0, 3, the end behavior. As we go to the left, it goes up. As it goes to the right, it goes up. So what shape is this? A U, it's a parabola. And does it give us any other points that it wants us to go through? So just graph a parabola, please. I'll do mine in orange. Why? Because I can. There you go. As long as it's a parabola opening up that goes through 0, 3, that's all you need. Questions, comments, concerns. Like I said, it doesn't have to be that parabola. If you want a fat parabola, it can be a fat parabola. If you want a skinny parabola, it can be a skinny parabola. It doesn't matter. All right, example 3. For all of you that ask, when am I ever going to use this in my life? Here we go. Let's find out when you're ever going to graph something in your life. Test drive. Hey is test driving a car she is thinking of buying. She decides to accelerate to 60 miles per hour. What does accelerate mean? Press the gas. Yep. And then decelerate to stop to test its acceleration and brakes. It takes her 15 seconds to reach her maximum speed and 15 additional seconds to come to a stop. Use the key features of the sketch to sketch a graph that shows the speed y as of time y. Like I said, 99% of the time is on the bottom. Y-intercept. Hay starts her test at a speed of 0 miles an hour. So please go to 0 and put a point there. So go to 0 and put a point. Linear or nonlinear? The function that models this situation is nonlinear. Why? Because she steps on her accelerator, she goes up to 60, and then what does she do? Lets off and puts the brakes, so it decreases. It's not just a straight line, it goes up and then comes back down. That is an absolute value. Extrema, her maximum speed is 60 miles an hour, which she reaches at 15 seconds. So go over 15 and up 60 and put a point, please. Over 15, up 60, and put a point. That is our extrema. That is a maximum, actually. Increasing. Hay increases the speed at a uniform rate for the first 15 seconds. So what you're going to do is connect from 0 to 1560. Draw a straight line, please. Decreasing. Hay decreases the speed at a steady rate for the next 15 seconds until she reaches a stop. Where did she reach a stop at? Well, she drove 15 seconds to the maximum speed and then an additional 15 seconds. So let's do some advanced math. 15 plus 15 is? So go over 30 on your x-axis. Put a point, please. And now draw a line from your maximum to your endpoint. End behavior. Because hay starts at 0 miles per hour and ends at 0 miles per hour, there is no end behavior. So book said so, so it must be true. All right, there you go. That's a word problem in Algebra 2 Honors. We survived it. Good job. Questions, comments, concerns? No? All right, let's look at example 4 then. Isn't this much better than handwriting every single part of this? That's what I was thinking too. All right, use the table and graph to compare the two functions. Where is the x-intercept at? -2, 0, right? -2, 0 right there. So please write that on your line. All right. I actually made a boo-boo there. That is an x-intercept, but it's not the x-intercept they want. So I apologize. It's early on a Monday morning. What they want us to do is actually graph this. So can we graph this? How many points do you need to graph a straight line? 2. So pick 2 points. Will -6 fit on your graph? So probably don't choose that one. Will -3, -2 fit on this graph? 1, 2, 3, 1, 2. So put a point there if you want. What would be another good point?
3, 0.
Okay. 6, 1 will not fit on your graph. So -3, -2, and 3, 0 would be 2 great ones. And then what should you do? Graph your line. Okay, and then let's answer some questions based on our new line. Where did it cross our x-axis at? 3. And if I'm going too fast, let me know. See, I'm not writing anything down, so I don't know how fast to go. Because I think we have just enough workbook, so I don't have an extra workbook I can write in. All right, where is... Oh, I should have read closely. F of x. So this graph is f of x. So where's the x-intercept of f of x? It's at 3. X-intercept of g of x. This one here is g of x. Where is the x-intercept of the graph that's already there? -2. f of x intersects the x-axis at a point farther to the right or to the left? To the right. There you go. All right, let's try another one. I'll do better on this one. Yes, I know. Go. All right, please go ahead and graph that line. Graph it based on the function table that's there. And I'll do the same thing. All right, do we have a graph? Do we need more time? Well, you're a superstar. All right. All right, hopefully your graph looks something like that. Yes, no, maybe so. Okay, Liana, is that good? You have that? Are you lying to me? All right, just checking. If I get up and look. I said that wrong. Don't make me get up and look. All right, so let's answer the questions that are in the book. Where is the y-intercept of f of x? Where is the y-intercept of our new line? I like that answer. Good job. Where's the y-intercept of the original graph?
4.
I like that answer. So g of x intersects the y-axis at a blank point than f of x. Is it higher or lower? It is higher. You are correct. All right, since you're all smart kids, do the next one on your own and the check, and I'll give you like 7 minutes to do both of them, and then we'll go over it. Thank you. Can you work together on this? The correct answer would be yes. You had a 50-50 chance. No Lexi today? Bailey, will you get that, please? Thank you, Bailey. Ari's here, though. Thank you, Ari. I was just talking about you. Okay, can you grab your workbook, please? I think Annalise went testing. Bailey's here, Riley's here, David's here. Albin's not here. Ruben's here. Murphy, I sent testing. Lily's here. Morgan is here. Caitlin's still not here. Michaela's here. Logan went testing. Sarah's here, pushing the limits on the tardy bell, but here. Chloe pushing the limits of the tardy bell, but here. Kayliana's here. Yelena's here. I hate to ask, but I have to. Is it Yelena or Yelena? That's what I thought after I said it. So, Yelena. Rana's here. KP's here. Sebastian's here. Aiden is not here. Savannah's here. Shelly's here. Alexa's here. Tasha's here. Logan's here. Wonder's here. James is here. Connor's here. Daryl's here. And Lily's here. All right, about 2 more minutes. All right, we good? Do we need more time? All right, looks like we're ready. Do I have a volunteer for number 1? Oh, it wants the slope of the line. Does anyone know what the slope of the first line is? Even though it's on the board. You have it backwards. You have the inverse of it. Because if we have f of x is our current line, right? What is the slope of f of x? All right, f of x is the one we graphed. Remember, how do we find slope? It's rise over run, Daryl. So we go up 1 and 1, 2, 3. So it's 1/3. But you were, I could see where you were going on that one. So thank you for participating and not taking selfies in my class. I appreciate that.
What if you wrong? If you said 2 over 1?
You're wrong.
It's wrong if you have to say 2. So just like I did over 1 to say over something.
Hold on.
On a test.
Oh, I thought you were talking about this one
No,
here.
the next one. Sorry.
We're not there yet.
Oh.
So now you're tardy. Now you want to be over 4. Go the opposite way. Daryl and I were talking about the slope of the other one. Sorry, Daryl.
Daryl.
All right. Daryl, if you want, let me know. I'll change your seat. All right.
No, me and Daryl chatted up.
That's a problem.
No, Daryl, aren't you chatting?
He's so chatty.
He's not awake yet. Wake up. It's Monday.
All right. Chloe, back to you.
Yes.
Slope of g of x. G of x is the line that's already graphed. So how did they get from this point to this point? They went up 2 over 1.
Okay.
Or, that says or, 2 over 1. Yes, either one is acceptable. My math is good enough to know that 2 over 1 is the same as 2. Most days, not always. Especially before 8 o'clock. It's sketchy on a Monday with a potential storm in the Gulf.
I know.
It's not potential, it's there. All right, is that it? Increasing, each function is increasing, but the slope of g of x is greater. Logan, everything okay? Oh, okay. I thought you were getting away from Chloe. I was like, what'd she do to you? Chloe's
No,
gonna
we
be
were both sprinting in class.
Chloe's gonna be sitting outside the door.
Dude, I have to do some fresh air.
All right, some fresh air.
Yeah.
Uh-huh. So g of x increases faster. All right, let's look at the check. Hopefully you did the check as well. Let me zoom out. All right, we have 16 minutes left. Let's keep going. Did you graph your line? The line hopefully looks something like that. Yes, no, maybe so. We'll go with that. Which statement about f of x and g of x are true? G of x has a faster slope than f of x. This g of x is going downhill. So is that greater than a positive slope? Savannah shaking her head no, and I agree with her. All right, so we'll go with that. The x-intercept of g of x, that's the one that's already there, is greater than the x-intercept. Is this point right here greater than this point right here? Yes. The y-intercept of f of x is the one that we graphed, is greater than the x-intercept. Is this greater than this? No, it's not. Oh, we said y-intercept. Is this greater than this? No. Both functions are decreasing. Are both functions going downhill? Lily says no, and I agree with her. Good job. F of x increases, so the orange line's increasing while the blue line's decreasing. Is that true? Ari shaking her head yes, and I'm going to agree with Ari. Good job. F of x has a faster rate of change. What's rate of change? I've never heard that before. Does anyone know another word? It is slope. Good job, Rada. So, all right, f of x has a faster slope. So what's the slope of the orange one? That is our f of x. It's positive, so it has to be greater, correct? Yes.
Yes.
All right, turn your page, please. Example 5. Compare properties of nonlinear functions. Examine the categories to see how to use the description in the graph to identify key features of each function. Then complete the statement to compare the two functions. So what you're going to do is graph your x-intercept at negative 3.4. X-intercept is at negative 3.40, so you should have a point at negative 3.40, such as I do here. Are we good with that? Pretty simple. Next, y-intercept at 0, 1.5. So go up 1.5 and put a point there, please. 1.5 for me was right there. Relative minimum is at negative 2.3. So go back 1, 2.3, and up 4.7. 1, 2, 3, 4.7 is going to be 70% of the way from this line to this line. And put your point there. So you should have a point there. Let me try and make this a little brighter. Oh, there we go. I wish they had that option for some of my students later in the day. So that was a dad joke. That was a math teacher joke. That was funny, but none of you got it. Okay. Thank you, Chloe. Chloe, did you know I'm so bright my parents call me son? I'll explain that to y'all later. So, all right, moving on. That's enough of the dad jokes before I get stuff thrown at me. All right. Relative minimum, go back 0.4 and up 1.1. So I put a point right there at 1.1. My end behavior. As x goes to the left, remember we read this negative infinity as to the left. As we go to the left, it goes down. So this graph needs to be going down. And as it goes to the right, it goes, Shelley says it goes up. And I agree with Shelley. Good job, Shelley. All right, so your graph, does it have to look exactly like this? No, but it should look something similar to it. So now we have to answer the questions at the bottom of the page, and then we're going to be done for today. Sebastian, I have some sad news for you. We don't have homework tonight. I'm sorry.
So disappointed.
You know what? It has nothing to do with school tomorrow. It has to do with Miss Taylor and I talking and saying, instead of having you graph every single one of these on page 37 and then answering it, what we're going to do is rip off a piece of chart paper, and each table is going to answer a problem instead of doing them all individually. Wouldn't that be a good idea?
So smart. Can I use the restroom?
You have 11 minutes, so you can. All right, let's answer these questions at the bottom, please. The x-intercept of f of x. So I'm going to actually put the graph up there so we can look at our graph and answer our questions based on the graph. And remember, the orange one is f of x. I will actually even write that for you so I don't get confused. F of x. All right, the x-intercept of f of x is what compared to the x-intercept of g of x? Is it less than or greater than? Less than. The faster you write this, the faster we're done with it. Or the faster you answer this correctly, the faster we are done with it. This orange point here is less than that point right there. The graph of g of x is the blue graph, intersects the x-axis how many more or less times than the orange line? More. That's it. Really simple. Right, Tasha? Right. The y-intercept of f of x is our orange line, so that is our y-intercept is right there. Is that less than or greater than the blue intercept? Please write that, less than. You are correct. So g of x is our blue line, intersects the y-axis. Is that higher or lower than that point right there? So please write higher. The relative maximum of g of x. So where's the relative maximum? So that would be that point right there, correct? Oh, sorry. Where are we here? The relative maximum of f of x. So f of x is, I thought that's what I just showed. I misspoke if I did. Thank you. The relative maximum of f of x is, what is this compared to this? Greater than or less than? Greater. All right, greater than the relative maximum of g of x. The relative minimum of f of x, so the relative minimum of f of x is right here. And what is that compared to this point right here? Is it greater than or less than? This point here compared to this point here. This point here compared to this point here is greater. This point here, this relative minimum is greater than this relative minimum. The two functions have blank end behavior. The same or different? Well, let's think about it. As I go from the center, as I go to the left, both graphs go down. From the origin, as I go to the right, both graphs go up. So they are the same. Shelley, do you have any questions? Anyone else have any questions?